In this lesson, I'll show you how to test for convergence using the root test with infinite series. The root test is shown right here, and we'll refer back to this as we do the two questions that we have. The question reads, what does the root test say about the convergence or divergence of the following series? The series is defined as 6 times e to the power of negative n plus 1, all of that raised to 4n. The first thing that I'll do is set this part equal to a sub n. And then I'll try to find the limit as n approaches infinity for the nth root of the absolute of a sub n. Now that I've set this up, I'll rewrite this so that it's in fractional exponents. Rather than having a radical, I'll write down 6e to the power of negative n plus 1. This is raised to 4n. And this is all being raised to 1 over n. According to the laws of exponents, I can multiply 4n with 1 over n, and what that will do is cancel out these n's, leaving me with the limit as n approaches infinity for 6e to the power of negative n plus 1, all raised to 4. Now remember, this expression is in absolutes. So my next step is to set n equal to infinity. If I set this equal to infinity, I'll end up with e to the power of negative infinity. That is equal to 0. Leaving me with 1 to the power of 4. That's equal to 1. And because I end up with an answer of 1, this is inconclusive. Take a look. Where if the limit is equal to 1, the root test cannot give us an answer. Let's move on to the next question. Here we have 9 times 2n plus 1 over 3n plus 4 all raised to n. I'll use the exact same technique as before. I'll set this as a sub n, and I'll take the limit as n approaches infinity for the nth root of the absolute of a sub n. Let's continue our work over here. So we have 9 times 2n plus 1 over 3n plus 4, and that's in absolutes, and it's being raised to a power of n. That itself is being raised to 1 over n. N times 1 over n becomes 1. And if I take the limit now, as n approaches infinity, I'll end up with infinity over infinity. So I need to manipulate this a little further. In addition, this 1 over n also gets multiplied to this factor. I nearly forgot. Setting n here equal to infinity makes this go to 1, because 9 to the power of 0 is 1. All I have to do is algebraically manipulate this, and I can do that by multiplying the top and the bottom by 1 over n. If I do that, this term specifically becomes 2. This becomes 1 over n. This term becomes 3, because the n and the n cancel out for the same reason. This became 2, plus 4 over n, making this n really large, and this one makes both of these terms go to 0. And we're left with 2 over 3, the absolute of that. Let's take a look. If my limit is less than 1, according to number 1 here, this absolutely converges. Therefore, this series converges. Now moving forward, you should be using these strategies to find out whether your infinite series converges or diverges. Always start with the convergence test, also known as the limit test, and I do have 2 videos on that. Then try the root test if all of the terms have an nth power. Notice the 2 examples here both had an nth power. And finally, end off with the ratio test, which is good for factorials and generally for others. So there you have it. That is how to test for convergence using the root test with infinite series.